If you look at how did life evolve on Earth, there are many theories. I mean, a kind of silly theory is that it came from outer space. That basically there's a meteorite out there that sort of landed on Earth and it brought with it DNA material. Basically, the next question is, how did it evolve over there? Whereas our planet has basically all of the right ingredients, why wouldn't it evolve here? So basically, let's kind of ignore that one. And now the two other competing hypotheses are from the outside in or from the inside out.
What's that mean?
From the outside in means from the surface to the bottom of the ocean. From the inside out means from the bottom of the ocean to the surface. Life on the surface is one option. And then the idea there is that there's tides with the moon and the sun sort of causing all this movement. And this movement is basically causing nutrients to sort of, coalesce and, bounce around, etc. That's one option. The second option, massive amount of energy under, from the core of our planet, exploited, leading to these basic ingredients of life forms. And what are these basic ingredients? Metabolism. Being able to take energy from the environment and put it as part of yourself. Metabolism, it basically means transformation. Taking stuff like nutrients or energy source or anything and then making it your own. The second one is compartmentalization. If there's no notion of self, there can't be evolution. You have to know where your own boundaries end and where the non-self boundaries begin. And that's basically the lipid bilayer nowadays, which is extremely simple to form. It's basically just a bunch of lipids, and then they eventually just self-organize into a membrane. So that's a very natural way of forming a self. And then the third component is replication. Replication doesn't need to be self-replication. It could be A helps make more of B, B helps make more of C, and C helps make more of A. Any kind of self-reinforcement is what you need to ignite the process of evolution. After you've ignited that process, you then, boom, have life going. And the moment you have A, B, C, some kind of thing looping back onto A, you can make modifications and you can improve, and then you let natural selection work. We like to think of life as the information propagation, which is DNA, the messenger, which is RNA, and then the action, which is protein. So basically, DNA, we think, is an essential part of life. That's where the storage is. And therefore, that early life forms must have had some kind of storage medium, DNA. If you look at how life actually evolved, DNA was invented much later. Proteins were invented later. And RNA was found by itself, thank you very much, in an RNA world. That early RNA world eventually got to replication, where enzymes encoded in RNA would replicate RNA itself. And then that process basically kicked off evolution. And that process of evolution then led to major innovations. So the most beautiful and most complex RNA machine known to man is the ribosome. The ribosome is this massive factory that is able to translate RNA into protein. The ribosome, if you want, divine intervention in the history of life, the ribosome is it.
That's one of the great inventions in the history of life.
Yeah. But again, you can't think of great inventions as one-time steps. They're basically, the culmination of probably many competing software infrastructures for life preservation that won out. And then when the ribosome was so efficient at making proteins, all the other ones basically died out. And then the life forms that were using the modern ribosome were basically the more successful ones because they could make proteins.
How hard is the first step? Or if there's something interesting you can say about that first leap.
Yeah.
About from not life to life.
I think it's inevitable.
On Earth or just
in the universe? I think it's inevitable. If you look at Europa, the moon of Jupiter.
It's also a really nice song by Santana. Yeah.
Europa basically has all the ingredients. It has, the core that can emit energy. It has the shielding through the ice sheet, protecting it, just like an atmosphere would. It even has a layer of oxygen, probably sufficiently dense to sustain life. So my guess is that there's probably independently arisen life form already teeming in Europa, because as soon as today,